lecture of the Vision Science 1. And so I will spend about maybe, I guess maybe about an hour, so to talk about some of the calculation involved in ocular accommodation. And tomorrow, so we are going to have the tutorial on optometer, followed by a lab sessions on heterophoria. So I have just revised the the schedules. So by combining the tutorial and the lab session, so that we don't have to like going to one room to another, to the other while switching to another classroom. So basically, we can stay in the same classroom for both the tutorial and the lab session for tomorrow. Okay. Okay, so back to this lecture. I think last time we have discussed we have done the calculation together, and as you can see here, this is talking about the near point and also the far points of accommodation, okay, for subjects with different refractive error. And as you look at the example, so here are the subjects who have no refractive error, myopia, hyperopia, both are uncorrected, and with the same magnitudes of the accommodation. And as you can see here, if you have no refractive error, so your clear vision, the range of clear vision is much larger compared with those, for example, with myopia. I mean, myopia in particular, you can see that the range of clear vision is very small. Okay, any objects beyond this range will form a blur image on retina. In people who have hyperopia, against the near points of accommodations will also be affected as you compare the first one and the last one, because we use part of the accommodation to compensate for the distant prescription, the heterophoria, the hyperopia. Okay, so this is when you do this example, so the assumption is that people are uncorrected. So meaning that they are not using any like a spectacle or contact lens. Okay. So this diagram illustrates how the amateur accommodate before and after the accommodation. So I just, in order to simplify this diagram, I actually combine the two scenario together. Okay. So if you look at this eye, okay, so this is the optical axis. So I combine the two situations together. The first one is when you are looking at distant objects. Okay. So when you look at the distant objects, meaning that you are not using any accommodation, so your far point, remember MR is the far point, is an infinity because this patient doesn't have any refractive error. So the far point of accommodation is an infinity. And so that when the eye is totally relaxed without accommodation, you can see that, so the light will fall on the macula or the fovea. So this is for the distant vision. And the lower part of the diagram illustrates the near vision. So when you have the maximum amounts of accommodation. So MP, remember, so this is the near points of accommodation, okay, in which you have the maximum amounts of accommodation. So when you reach the maximum, okay, so this L, so the reference point is taken at the principal plane of the eye. So is the object distance. So from the eye to the objects. So is called the object distance. Okay. So this is when you have the maximum levels of accommodation, and of course, without accommodation, without accommodation, if you put objects here, so the image should be forming behind the retina. But since you are using maximum amounts of accommodation, now you can see that the image is still formed on the retina. Okay, so the lower part illustrate when the eye having maximum amounts of accommodation. Of course, the k pi, which is the axial length, does not change. Okay, before and after accommodation. So as mentioned, so this the upper part represent the situations where we have no accommodation, and the lower part is when you have the maximum amounts of accommodation. So you are fully accommodated, and the and this is the position of the objects, okay, where you have the maximum accommodation. And if you take the reciprocal, so you will be able to get the object's versions, okay, the big L. What about myopia? For myopia, the situation is more or less similar, except that if you look at the upper part of the diagram, so the far point of accommodation will be positioned in front of the retina instead of at infinity. So the far point of this patient, when they are myopic, so the far point has to be somewhere in front of the eye, patient eye. Okay, so this illustrates the far point, and when the object is at far point, of course they can see a clear image. So this is for the distance. Near vision is more or less the same. So when you move the objects to this position, so this is the positions where you have the maximum amounts of accommodation. And then, so the same diagram, of course, the with a clear image on the retina. So this represent the eye without any accommodation, okay? And this is the second part. Okay, maybe I can talk a little bit more about this one. Okay, so this is this represent the eye with the with no accommodation. Okay, remember, so this is the far point. So the if you take the distance from the eye to the far point, so you will get the small k, which is this far point distance, remember? So this is the far point distance. And if you take the reciprocal, so you will be able to get the ocular refraction, which is the big K. Okay. Actually, the same apply to the last diagram too. Remember, if in the last diagram, so the K, the far point distance will be at infinity. Okay. The difference is that the small k will be at infinity, and therefore the ocular refractions will be equal to 1 divided by infinity. So this is very close to, is close to 0. Okay, no refractive error. So this is the situations where you have a myopic patient. So, and as you can see, the k will have a small k with a negative value, and so does the big K as well. So this patient is a myopic patient with a negative refractive error. The lower part represent the eye with maximum of maximum amounts of accommodation. So everything's are the same as the last one. In this case, again, if you take the reciprocal of the object distance, so then you'll be able to get the object's vergence. Okay, so if you look at the upper part for the situations without accommodation, so we use this formula. I mean, I hope you still remember this one. Okay, so this is the actually is k plus f equal to k pi. Okay, the k is ocular refraction, f is the total power of the eye, k pi is the object length of the eye. Okay, so we can use this diagram to illustrate the situations where you have no accommodation. So Fe is the total power of the eye in the relaxed condition. If you look at the lower part of the diagram, where we have the maximum amounts of accommodation, so remember we will have this one. Okay, so this could be L pi or K pi. I mean, it doesn't matter because this is talking about the eye condition. So the meaning is exactly the same. Okay, so under these circumstances, so the objects will be, instead of located at the far point, so will be located somewhere in front of the eye, like this one, or the other one. Okay, so when you have the maximum amounts of accommodation, so we have the object's vergence, and then we of course we have the total power. The total power of the eye has two components. First one is the Fe, is just refer to the refractive power of the eye in the unrelaxed condition, plus the accommodations, because on top of that, so the lens will change in position. I mean, lens will change in the power, so that on top of that, you have to add another A, which represent the accommodation of the eye, so will be equal to k pi. K pi is the object length of the eye, because the eye length, I mean the axial length remain unchanged before and after accommodation. So if you combine these two equations, because this is k pi, this is k pi, so you can basically combine these two equations. So k plus f equal to L plus f plus A. Okay. So if you take away the f, so you can see that k is equal to L plus A, or A will be equal to K minus L. Okay, so this is the equations that we can use for calculating accommodation. Okay, it's called the accommodation formula. So accommodation would be equal to the ocular refractions minus the object's vergence. Right? I think this equation makes sense because, for example, if you have 3 diopters of accommodation, 3 diopters of myopia. So if you have 3 diopters of myopia, so that means the K would be equal to -3. And then if you look at the objects at 33 centimeter in front of the eye, okay,